Welcome back. This is part one, looking at what is R and how does it work. So we explain a little bit about what R is and what we can do with it. So just a very quick recap, what is GIS? GIS is Geographic Information Systems, and it's anything to do with maps and spatial data. And it's all about turning spatial data into information. So when I'm talking about spatial data, I mean data that has some sort of location element to it. It could be a postcode, it could be an address, it could be a set of coordinates, it could be a country name, anything like that. And how we turn that into information using our GIS program, but also then how do we then use this information to answer questions? So our questions might be research questions, for example, how have housing conditions changed in the past 10 years? But these questions will really vary. It depends what your area of interest is and why are you using the GIS in the first place. R is very good at creating maps. So here's a couple of nice examples looking at some census data from 2001. On the left, we've got the percentage of people married in Liverpool, and on the right, the percentage of people aged 20 to 24. And R can create all sorts of useful and interesting maps, and we'll do a little bit of that in the course today. One thing about R is it works as a very different program. So it's command line driven rather than a graphical user interface. So it works very differently, say like than Word or Excel or even ArcGIS if you've used that. With those programs, you might use the menus to do things. You might press buttons, there might be some wizards, that sort of thing. Whereas R is command line driven. So that means you type in a command, press enter, and it does something. So it's a very different way of working. There are some disadvantages to this. You know, there's no getting around that. Firstly, remembering the commands. Yeah, when I first started learning R, I remembered remembering what these actual commands were often took a little while. And I've put together a glossary for you, so you can see that in the link on the webpage. And that will help you remember the command, and you can use that as a reference, and you can add and update things yourself. R also does have a steeper learning curve. So it's a really powerful tool, but it can take a little bit of time to get your head around what's going on. So if you do the first steps and thinking, oh, I can't do this, don't worry, do persist and you will get there. However, there are loads and loads of advantages, which is why it's becoming such a popular tool. Because it's command line based, or it's what we might call a script based, it's very easy to record exactly what you did and repeat specific pieces of work. So we have these things called scripts or codes, and when you write those down, that records exactly what you did. And because it's scripting, there are lots of reproducible examples on the web. So you'll see a few web links beneath examples, and all of those have the R code available. So it makes it very easy for people to say, this is what I did, and you can replicate that. It's also easily scriptable, and by that I mean we can utilize some kind of key programming concepts like loops in computer science. For example, if we wanted to create, take some data and create lots of maps with it, we can do this quite easily. A colleague of mine, Alex Singleton, he wanted to map all of the census data, which is about 390 odd variables for each local authority in England and Wales from the 2011 census. And so that, you know, there's 354 local authorities, so that gives us about 134,000 odd maps. So a huge number of maps. If we had to do that kind of by hand, as it were, in ArcGIS, it would take us absolutely ages. But we can script this in R and we can create loops. So we can tell R to create a map for all of the 400 variables for this local authority, and then repeat it for this local authority, and repeat it, and repeat it, and repeat it, and repeat it, and so on. So it's a really powerful tool, and we'll do that in part 3 of the course. The URL is there at the bottom if you're interested. And this is some of the examples from the Census Open Atlas. You know, given that we're now in 2020, 2011 is quite a long time ago, but you can see the principle, and it's a really valuable tool. So we've got some maps of economically active full-time students. We've got some maps of different age groups, 18 to 19, 20 to 24. We've got some maps of the proportion of the population who are single, who are married. And we've got for different areas as well. So for example, we've got Liverpool and we've got Manchester, and this is ethnic group, so the percentage of the population who are white. R is also a really good graphic tool. There's lots of interesting graphics you can do with it, and this is where a map I particularly like. You know, this is more kind of art than science, really. It's looking at undersea topography, so the depth below sea level. And again, there's a link there, and you can create that map in R. This is another nice example that cropped up looking at population in Europe. So you see we've got these spikes here. So we've got spike for London and Paris and Madrid and so on. And this was done in R. And this is the code that we used to create this map in R. So it's not a lot of code, it's maybe 15 lines, maybe a little bit less. And by the end of this course, you'll be able to interpret some of this. And with a little bit of extra work, you should be able to recreate this map, no problem. Just to flag, we do have other types of GIS software. So you may have used ArcGIS before, or MapInfo before, or QGIS. R is very, very different to all of those, but it can do many of the same operations. One thing I should point out is R is free and open source. QGIS is also free. ArcGIS and MapInfo are professional commercial programs, so you have to pay to use them. And R is becoming increasingly popular in the academic sector because it's open source. So that means it ticks a lot of boxes for reproducible research. The idea being that the research we do, it should be replicable by someone with a similar level of knowledge. If you do your research in a closed source program you have to pay for, then it's hard to make the case that that is reproducible because you need that piece of software to reproduce it. Whereas with open source software, anyone can download it and install it. I would also say that if you know QGIS or ArcGIS or MapInfo or some other GIS, feel free to try things in there as we go through this course. You know, we're using R and RStudio, but try it in a familiar software if you want to. And the other thing to note is all of this software can be really useful. There's a huge variety of pieces of software out there, and not one of them will solve all your GIS problems. So you may end up using one or more programs together. I often use R and QGIS in my day-to-day work because some things I find easier in Q, some things I find easier in R. So do experiment and see what works best for you. For the work we're doing in this course, we actually are using two programs. So we're using R and RStudio. So R is the program that sits underneath, that does all the kind of heavy lifting, that actually runs the command. And then RStudio is the interface for it. So RStudio is the program, that's what we open and that's what we interact with, but R is the program that actually does the work. So if you don't have it on your computer already, you need to install R on your computer first and then install RStudio. There are some links in the handout if you need some instructions on how to install them and where to get them from. Once you're all installed and set up and running, this is the RStudio window. You see we've got three kind of key bits here. So we've got the console on the left-hand side, and then we've got the environment on the top right, and the files and the plot window on the bottom right. And I'm going to say a little bit about each of those as we go through. R has this concept of working directories, so it uses a folder or to store your files in, and you might have a different one for each project or each piece of work. So you might create a separate one for each course that you do in R, say. And we have to tell R which folder we're using for this, which directory we're using. So for example, we might write in this command, which says we're using the GIS folder in the documents folder in the C drive. You can also use the graphic interface to set this and to browse like you would the normal Windows Explorer window or Finder, depending on what laptop you're using. R uses the concept of variables to store information. So a variable is a kind of discrete thing, and it can contain something that we use in our work. And it lists these in the top right. One example might be this one at the bottom, and I'll just go through how we kind of create this variable. So we've got to give it a name. Every variable has to have a name. So we might call this one house.prices. We can't use spaces in variable names, so sometimes we use dots instead. And then we use this assign to symbol. So it's a less than symbol and then a hyphen. And then we say what is the variable, the data that it actually has in it. And so here we have a list. We have a list of numbers. So we've got 7 numbers here, 120, 150, and so on. So we run that command and it stores that in R. R handles spatial data in exactly the same way. So we might have a variable called St. Helens, and we're going to store a shapefile of the St. Helens area. We use the same assign to symbol, so less than and hyphen. And then we have this. So this is a function, st_read. And this is a function that says, take this file name and then read it into R. And so the file name here is sthelens.shp. And so that will look for sthelens.shp in your working directory and read it into R. There are some more details in the glossary. One key thing to say is that R is case sensitive. So this goes for variable names, this goes for function names, and most things in R. So for example, if you did St. Helens with a capital S and capital H and called that, created a variable called that, R would think that is a different variable to St. Helens in all lowercase, and that would again be a different variable to St. Helens in block capitals. So there's various different conventions, but it's good to be consistent. And you'll see how we do that in the practical as we go through. One thing also worth noting is that R has many different data types. So it's got different types of variables to begin with. So we might have what we call a vector, which is a list of data points. So for example, our house.prices, we had a list of these 7 numbers, and that is a vector. And we also have these things called data frames. And so this is like a table. You can sometimes call it 2-dimensionals, because we go across and we go down. There are many other types of variable R can store, and you'll see references to them. I'm not going to go into detail now because it's not relevant for what we need, but if you want to find out more, you can. R can also store different types of data. So this is in terms of what's actually stored in your variable. So the 2 biggest ones are numeric, which is numbers, so 1, 2, 3, so on, or character, or what we might also call string if you've got a computer science background. And so this is letters. These is either words or sentences or individual letters. We have this function called class that we can use to see what type of data a variable is stored. So if we look at our house prices variable, if we type in class, open bracket, house.prices, close bracket, and press enter, R will then tell us what sort of data is stored in. So it's saying numeric here. So it's telling us that the house.prices variable contains numbers. We also have data frames, and we can access different elements, different bits of this data frame. We can think of data frames as like a table or a spreadsheet. And then we use these square brackets to access the different bits. So we can do the name of the data frame, square bracket, and then rows and or columns. If we want just a specific row, we can do 1, blank, and that will give us the first row. Equally, we can do blank, 1, which will give us the first column. We could also pick out a specific cell, if you like. So data frame 1, 1 would give us the cell where the first row and the first column intersect. We'll be using this later on to extract different bits of data. R also has this concept of libraries, which is fundamental to how R works. R uses libraries to extend what it can do. When you first load up R, you get the kind of what we call the base function. So this is just the kind of general functions. But if you want to do anything more interesting, more advanced, like some GIS, let's say, or create some maps, then we need some additional libraries for that. If you're working on your own computer, you'll need to install the libraries first. Yeah, and we use the command install.packages for that. And then you also need to load the libraries. So we use library for that. Now this is an important distinction to talk about, because we have to install the package once. We only need to install it once on a particular computer, but we have to load it many times. So for example, we can think of it as a bit like a light bulb. You only have to install the light bulb, physically put it in the light fitting once and it's there. But if you actually want to use the light, you have to turn it on. You have to press the switch on the wall. And so we need to load the library to use this library function every time we start up RStudio to tell R that we're going to use this library. I should also say that R uses the words libraries and packages interchangeably. They mean the same thing, and sometimes you'll see it referred to one as a package, sometimes as a library, and they're essentially the same thing. So that's a kind of very brief whistle-stop intro into R. Part one of the workbook is below. So there's some text to read and some commands to go through. So have a go working through that. I would recommend you type out the code. Don't just copy and paste it from the window. Why am I saying that? It's not just me being mean. It does actually help you. It helps with the learning process. So it does make you think about what you're typing, and it will sink in more. So I would really recommend you don't just copy and paste, you actually type it out, because it will help you remember it in the future. I also guarantee that every single one of you will make typos as you go through. That's to be expected, don't worry. If R doesn't seem to be responding, or it gives you some sort of weird error message, just try typing that line out again. You're not going to break anything, so do have an experiment and see how we go. Then I'll see you in part 2.